Welcome to Visual Studio Debugger Tips and Tricks. My name's John Cunningham, and I'm the development manager for Visual Studio's diagnostics team. Now, the Visual Studio diagnostics team owns the debugger, the profiler that ships in Visual Studio Team System, as well as some of the new features that you might have seen in some of the talks highlighting VSTS 2010, which is the application flight recorder historical debugger, as well as the test impact feature. I've been with Microsoft about 10 years. I started out as a developer on the VS debugger. I was developing the native part of the debugger. I owned breakpoints and symbol stuff. But I've been doing debuggers for about 15 years, all my professional life. The reason I got into it was this. Can I get a raise of everyone's hands who uses a compiler on a day-to-day basis? Raise your hands, use a compiler. All right, keep your hand up. Keep your hand up if you took a course in compilers at school, in CS. Yep, still a big number there. OK, raise your hands if you use a debugger every day. You're in the right talk. Well done. Now, keep your hand up if you took a course at school that taught you how to write debuggers. Yeah, there's my point exactly. So I always felt when I was using debuggers at school that, wow, really, we don't talk about this very much? And so this was an area that always interested me, and I got fired into. I'm going to go over some tips and tricks in the Visual Studio Debugger. Some of the tips that I'm going to show are in existing versions, going back to Visual Studio 2005. But I'm also going to show some of the newer things in Visual Studio 2010 that will be coming out. I'm going to cover each of these areas. So execution control for us is where you're stepping, how you're stepping around your code, breakpoints, symbols, multi-threaded debugging, and post-mortem debugging. I also thought it would be quite fun if we took a little bit of a look behind the magic. How does the Visual Studio Debugger work? How does it do its job? I'm kind of hoping that this is a crowd that can appreciate that sort of thing as well. I'm calling these my int3 sections. Raise your hand if you can tell me the x86 opcode for int3. John Robbins, put your hand down. And Rick Byers. OK. OK, so a bit of a managed crowd in here, I think. Anybody, who else raised their hand there? OK, come see me for swag at the end, and I'll try and reward the opcode guys there. OK, the first thing I wanted to start on was that lots of people come to me and say, oh, I didn't even realize that the debugger debugged this particular type of environment. We support native debugging for x86, for x64. Can I get a show of hands of people who are doing 64-bit now? Good mix. That's some good stuff interesting to you later on, I hope. We also do managed code, both for Windows, but also in the embedded SQL CLR case, where it's embedded right into SQL. And script, T-SQL, native device programs, and many more that ship in the box, but also that third-party partners actually provide. And for the first part of my int3 sections, I thought I would talk a little bit about what the VS Debugger architecture is. You can see on this slide, you have right at the top the VS Debug package, which is the piece of code that's responsible for all of the windows that you actually see in the debugger. Threads window, locals window. It's the thing that's responsible for putting the yellow glyph and the red glyph on your code. Next, we have the SDM, something we call the Session Debug Manager. What piece of code would be complete without a manager of some sort in there? And you see two blocks underneath called CPDE and NatDBGDE. Those two chunks of code are responsible for the real engine work that goes on interfacing with your program and the debug hooks that are in other operating systems. Can someone guess what NatDBGDE came from? No guesses there. It's the native debug engine. CPDE, anyone got any ideas where that came from? Yep. Gentleman in the back, if you can shout out. There was one hand raised at the back. Correct, Com+ debug engine. Back in the days when, before the CLR was actually announced, it was Com+ was the name that was used for it. You can also see some blue extensibility points here. The debugger is built from a perspective of trying to allow other people who are targeting other platforms to be able to plug in. So you can see your engine here is set on the board there. If you're building a managed language, say, for instance, the IronPython group or something like that, they build expression evaluators into our existing managed debug support. And I've left a link in there if you're more interested in how we actually extend the Visual Studio Debugger, if that's something that's interesting to you. Control. One of the pieces of feedback that the debugger team continued to get over the last 3 to 5 years as we actually started to really roll out .NET adoption was the debugger steps in too much. And of course, we're scratching our heads going, well, when you step in, it goes exactly where the comment was coming from. But over the last 3 or 4 years, we've been writing a lot more managed code ourselves, and we start to understand what people's perspective is there, in that managed code with all of the properties and operator overloads has you with a much finer grained execution path than a lot of native code that's out there. So new to Visual Studio 2008 SP1, can I just get a quick poll? Visual Studio 2008 users in the audience? Great. Who's downloaded SP1 so far? All right, so you maybe don't even realize that this came with your SP1 download, but the debugger now automatically tries to step over any simple property or simple operator to try and make sure that you're stepping to only the things that you actually care about, the big methods that you've created. Of course, there's sometimes when you're going to need to step into those operators. You're really going to want to say, OK, I've got some complex operation in there. I need the get to be able to execute that code and trace it through in the debugger. We also support a right-click, step into specific. And when you right-click, you'll be able to see all of the target methods that are available that particular line of code is going to try and invoke. And you can select the specific one that you want to step into. For people who want to go back to, I really do want to step everywhere, you go to the Debugging Tools Options page in the General tab and uncheck Step Over Properties and Operators. For my next Int3 section, I thought I'd talk a little bit about how we made this work. It's not a hugely complicated algorithm. When we're doing step filtering, if we decide that if we've decided that the step complete has gone outside of the range that we normally set up for that step, we decide, OK, that's the step over. We managed to step over the line. We didn't actually step into anything. But if we complete as a step in, we go ahead and take a look at the current location, have a look at the metadata that's associated with that, and say, oh, this is really just an operator or a property. Let's step back out to the location that we stepped back into. In the case of step into specific, we have to do a little bit of understanding of the program about where we actually are. So we'll take a look at that particular range of code and go disassemble the IL so we can find out all the different targets there. When you select a specific call, we again do the step into. But in this case, when we complete it as a step in, we have to look not only at the target method, hey, did we arrive in get underscore my value, but is it the actual instance that you cared about? Because the debugger is smart enough to know that if you call get my value twice on the same line, if you selected the second one, we really want to make sure you're arriving back at the point that your return address is actually the place where that second invocation came from. So hopefully that's kind of interesting to you folks. So next I'm going to talk about breakpoints. As I said earlier, breakpoints is one of the first features I owned in Debugger. And so it's pretty close to my heart. Back in 2002, between the Visual Studio 2002 and 2003 release, I spent a summer trying to debug an addref release problem. Anybody in the audience debugged an addref release problem? Yeah, a few of the old native heads in here. That's great. The Visual Studio shell has a lot of COM objects in it. So I spent a good summer trying to deal with this. And one of the things that I came up with was I constantly really couldn't use just break and inspect. I would end up breaking at a breakpoint, writing down a stack, going, OK, this is this addref. Continue on, break, writing down this particular release, and trying to do, on paper, the matchup there to say, hey, here's the addrefs and releases. So that summer, I decided to do something about it and wrote the trace point feature. Has anybody come across trace points in the debugger so far? OK, so this is going to be new to a bunch of people. It's actually been in the product since 2005, but I don't think a number of people know about it. So what trace points do is let you print a variety of program state types without stopping. You can generate a huge amount of information about your application from correctly placed trace points to understand some of the history about how it's gotten to any particular state. You can do program location. You can even dump the stack out of how you got to that, which was really key for my addref release problem. You can also dump expressions. You can even, if you're using native code, you can use the special magic @CLK variable to do some timing. You can dump thread info if you're having a multi-threaded problem. You can say this particular breakpoint fired on thread ID 1 or thread name foo versus thread name bar, or any particular message that's going to help you solve your problem. But one of the other powerful features is you can run a macro from any given trace point. And that gives you a lot of power over being able to understand much more about the program state. So while in the first one you can print the stack out, in a macro you can actually reason about the stack and say, well, if method foo was in my call stack, I really want to stop only on that time, not when bar is in the call stack. There is a little bit of a performance cost because if I go back to that diagram, the macros are run in the context of the Visual Studio package as opposed to right down at that engine level. In these earlier cases where we print the program state, we do that very close to where we get the breakpoint to try and make sure that we're doing all of our evaluations as quickly as possible and letting the program continue on. But once I've built up my breakpoints to solve a particular problem, one of the problems I faced was, well, I'm kind of the expert in my domain. How do I help somebody else debug the problems in my area? I'm expecting the PDC audience, you guys are kind of the experts in your domain, and you're the ones that are having to help a whole bunch of people in your organization to debug particular problems. So one of the things that's new in Visual Studio 2010 is that we've added support for tagging, filtering, and import and export of your breakpoint groups. And so rather than try and explain that, I'm going to pop into a demo here and show you. So I don't know if it's too soon with the current financial crisis, but my demo app is an application that models the financial system. It's direct from the greatest minds in Wall Street. And you can see that it uses some particularly interesting mechanisms to understand where the stock prices are going to be. A great system called random numbers. The application is made up of two parts, the random number generator that generates where the stock market is any day, as well as an analysis model that is trying to say, hey, you should buy or sell at this particular time. So if I go ahead and run that, and my VPC starts to chug, you'll see that I'm able to select different app models to say, oh, do I want to be aggressive in my buying? And so I can select reckless abandon or run and hide, which I think is pretty topical. But if I'm an expert in this particular area, say I'm only an expert in one particular module, so this particular chunk here meant models right here. If I'm a developer in that area and I want to define this is how I want to log information from this particular part of the app, I would go ahead here and maybe set a breakpoint. My app is behaving. On each of these current analysis chunks from these classes. So hold. And if I want to be able to convert those breakpoints into trace points, I wander over here to the breakpoint and right-click. Some of the best debugger features are always hidden behind the right-click. And use the when hit option on that case. And you can see I get a lot of information on this dialog to help me to be able to set the right kind of trace points. The default one is to just print function and thread name. But for my particular issues, I'm going to say, no, I actually need a call stack here. And I've left it with continue execution. So I'm going to convert both of my breakpoints here to trace points, with both of them saying stack. And I'm going to let that run. And then in the debug output window, once we finish loading, we'll start to see the traces that I've inserted there giving me information as opposed to, and I managed to get the wrong variable, as I run that program, I now get information directly from it rather than stopping the application. But like I said, how do I give that information to other people? So if I go to the breakpoints window, new in 2010, now I can label these breakpoints as something that are in my group. So I can go ahead and say, edit labels, and give these the label jock can debug, which hopefully is true. And then if I had added another one, I can go and select that one that had already existed. If I set a further breakpoint, I can show you once you had gotten to 10, 15, 20 breakpoints, they start to become unmanageable. And now I can do a search and find just my breakpoints in that particular area. And finally, I can go ahead and select these breakpoints and export them into a simple XML file that can be given out to anybody that I need to help bootstrap them to debug in a particular application. I'm going to switch back now. Feel free to spontaneously applause at any time. That's what I'm talking about. OK. Native and managed. So I'm going to point out anything that doesn't work on native code. The step filtering that I talked about doesn't work on native code, but native Visual Studio actually had support for that before managed code. So that already works. So symbols. Symbols is something that's pretty close to my heart as well. As I mentioned earlier, it was one of the first things I owned at Microsoft. It was also my first job out of college. I worked for a very small debugger company in Scotland. They got me in, baited and switched me with, here's this beautiful, amazing debugger, sat me down and said, so John, Microsoft just released this new product called Visual C++ 2.0, and there's this new symbol format called PDB. You need to write the support for that. So over the next 3 months, if you think Microsoft documentation is pretty bad just now, I had a 2-page document by Jan Gray and one other guy and a binary editor. And for 3 months, I spent trying to figure out how PDBs and symbols worked, which was a lot of fun. So needless to say, these things are pretty close to my heart and dear to my heart. The one thing I want to make sure everybody walks away with here is that for symbols, you have got to hold them, squeeze them, and never, ever ship without archive them. If you ever ship without archiving them, I would fire you. I don't know that that's a Microsoft policy, but it's my policy. I would sack you. Now, in other climates, maybe I could have it as a capital offense. But I really want to make sure that everybody knows symbols are the lifeblood of how you diagnose problems once issues are in the field. If you've shipped your app and you don't have symbols for it, you're aiming for a world of heart of trying to diagnose any particular issue. Debugger is only as good as the symbols that you provide it. Always make sure that symbols are switched on for final and retail optimized builds. So a common complaint I get is, well, we don't want to ship the debug bits. Well, that's not really what I'm asking. Having symbolic information is not the same as optimizing your code. Not optimizing your code, I should say. So make sure that you've actually switched on symbol production. Now, by default, all of our wizards and projects that we produce in Visual Studio 2008 and before, I think Visual Studio 2005 we changed this, do produce symbols on the retail and optimized builds. But if for projects that are older that you've perhaps converted, I want to make sure you go back and ensure they're on. I also want to make a plug for using Symbol Server. Who in the room has heard of Symbol Server? OK, Pat Style, stand up and take a bow. So I have the author of SymServe and SourceServe here. He's personally saved our lives a number of times. And I'm going to make that an awful lot easier for you with the advent of Visual Studio 2010. The Visual Studio Team System product and the Team Build product is actually going to have support for Symbol Server and source indexing built right into. Now, I don't have a demo of that on my machine. I've got a video of that. I'm afraid it's not available in the CTB bits that you're going to get today, but it is going to be available in the first beta of VSTS 2010. And so with that, I'm going to switch over and let you see that support. So you can see here, if I can get this full, that I have a build definition here. And in the new build definition editor window, I'm going to go and select the processes that go with that build. I drop down, and I look at the compile and test section. And new in this particular area is index sources and publish symbols. So I can select those areas, format symbol, and provide to it, if the video cooperates, the particular place where we're going to ask the system to publish the PDBs to. And it gets to the publish symbols case. Come on, video. There we go. So now you can scroll down and select, here is the share that I want to store my symbols on. So there's no excuses now. With VSTS 2010, this is drop dead simple. For your final builds, maybe it's not every CI build, but certainly for your final builds, there's no excuse now not to have it indexed and ready to go for everybody. And with that, I'm going to kill that one. And again, spontaneous applause is warmly received. Another thing I want to say about symbols, who's a Scott Goo blog reader? Scott Goo blog reader? Yeah. So it may have been hidden away in Scott Goo's blog, but recently our team worked with Sean Burke from that group, making sure that people had access to the .NET framework source. We've made that even easier in Visual Studio 2008 SP1. You maybe don't realize it again if you've downloaded 2008 SP1, that to enable stepping right into the .NET framework, it's as simple as going to the debugger options dialog and checking that checkbox. And from then on, if you F10 or F11 directly into the framework call, it's going to go and fetch the source directly from the public symbol servers. You can also go ahead and force the Visual Studio Debugger to go and load symbols for any of the native or managed symbols that are up on Microsoft symbol servers directly from this dialog. These buttons are new in 2008 SP1. So another one of my int3 sections, I wanted to talk a little bit about symbol loading internals. We get a lot of feedback that my symbols don't match. I can't get it to work. I also get a lot of requests for, couldn't you just match yesterday's symbols? Isn't it close enough? Well, it turns out that it's not. I think if there's a difference between Visual Studio and WinDBG here. WinDBG does actually support fuzzy matching. And Pat, could you stand up? So before WinDBG added that support, Pat had hair, and now he doesn't. So we just never get to it. It takes people off in the wrong direction too many times. There's very subtle nuances in how the compiler is optimizing code, so we just don't do it. Never, never, ever are we going to do that feature. I also want to talk about how we try and find those symbols. The first thing that we always do is the exe, or the DLL, the module, has the path where that PDB was written directly built into it by the linker. So that's always the first place that we look. So sometimes you don't even have that drive available if it was built on a build server. The next path that we look at is the path that we create from the symbols dialog that I just showed you on the screen there. But other paths that we use are ones that are embedded in the registry and ones that are in these environment variables in that order, actually. These come directly from WinDBG support. We share the same mechanisms at the very lowest level in how we find our symbols. If you're trying to figure out why didn't you find my PDB, we actually capture the information of every place that we've looked, every PDB we've tried, and why we decided that that wasn't the right PDB to load. So to go and get that information, you right-click on the module in the modules list and say, show me the symbol load information. Multi-threaded debugging. So hands up, who's had a multi-threaded bug? Keep your hands up if you fixed it in less than 10 minutes. OK, that's, you can apply directly at Microsoft.com's careers. We'd love to have you in our team. Who can tell me, I mean, ballpark figure, how many threads do you think Visual Studio has when it first starts up? Ballpark. Shout them out. One. No. I wish. Close. 12 is close. 15. 15 threads without even doing anything. That's what Visual Studio has when it starts up. By the time you load a project and a solution, and step into it, we have 30 threads. So multi-threaded debugging is something that is a pain point for us as well, and something that we've invested in Visual Studio 2008 and will continue to in 2010. New in VS 2008, we added support for thread categories and flagging, which I'm not sure that many people have actually seen. And I'm going to go ahead and jump into a quick demo again to show you some of those multi-threaded features. So if I go back to my amazing application here of the stock models, and I hit F5 to start us up, I'm going to go ahead and break in so that we can see the thread pane in Visual Studio whenever it comes up. There it goes. VPC performance. So if I bring up the threads window now, Control-Alt-H, you'll see that we added support for categories. Now, in Visual Studio 2008 and the .NET Framework 3.5, we don't have too many categories at the moment, but this is something that you're going to see us continue to expand in later releases and try and improve. You'll also see the name that we've captured. One of the key things that you're going to have to remember with your multi-threaded apps is to make sure that you name your threads. That's trivial in managed code. In native code, we actually have a helper that supports doing a thread name via magic exception that is a contract between the CRT and the debugger to say, hey, here is a block of information that names and identifies this thread. I'm going to let it continue a little bit and break in again. And now you can see these other threads that have been named DGIA thread, NASDAQ thread, S&P thread. One of the things that we found when we were doing more multi-threaded debugging ourselves in both Visual Studio 2003 and Visual Studio 2005 is that we'd invented a magic little game that we'd never expected to. It was called Hunt the Thread, where you would spend all of your time clicking on a thread, looking at the call stack window going, that's not my thread, that's not my thread, that's not my thread. And so we added support in the threads window this time around to actually hover and show you the stack directly in the threads window for that. So now it's a, thank you very much. Now it's a simple job of just wandering around the thread window to get those stack tips up and find exactly where your code is. Something else people don't realize is that we added support for flagging your threads. So for instance, in this case, I have a thread responsible for each major index. I can go ahead and say, these are the important threads to me. And now I can show in our new improved debug location toolbar, I can select the show only flag threads and then select very quickly into each of these different threads to understand where they are at any given time. Finally, the last thing I want to show, second last thing I want to show is that if I'm wanting to make sure that these threads are not moving, I only really want the DGIA thread to run, I can go ahead and select those and freeze these. And you'll see that there's a pause icon appears right in the thread window here. Or I can go ahead and thaw them and let them run. And then finally, one thing that's, again, hidden away on a context menu is that we actually have support for thread-specific breakpoints. Again, I'll bring up the context menu on the breakpoint and use this filter. And now I can actually go ahead and say, thread name equals jocks thread. And that would make sure that that breakpoint only fired on that particular thread, which can help an awful lot when you're doing multi-threaded debugging. So just to recap, use the select filter to set thread-specific breakpoints. Freezing and thawing, which is click on the thread and select freeze thaw. Stack tips and thread flags to be able to manage your threads better. And naming threads. Again, it's really trivial in managed code, but you'll need it after the fact that you've shipped it without thread names. You'll be cursing yourself for not doing it. And in native, we have a wrapper. A member of our team, Stave.js, has a pretty good blog article on exactly how we do thread naming, so I'd like you to go and take a look at that if you're interested.
Are all these possible in 2008?
All of these are possible in 2008. Everything I've shown you there is 2008. We are making major investments in this area for 2010, but nothing that I'm ready to show you today, sadly. If you perhaps give me enough beer, then maybe we'll talk. Lastly, I'm going to talk about postmortem debugging. Who has debugged in the Unix world? Unix guys, you lived on core dumps, right? But for a long time in the Windows world, we haven't really had the same capabilities as folks from Unix. It's not been a big part of what Visual Studio and what Windows debugging is about. It's going to be increasingly important over the coming years that we actually have much better postmortem support. Microsoft is continuing to invest in Windows error reporting. I'm sure you guys have seen the dialogue that comes up saying, this program has stopped working, please send information to Microsoft. If any of you in the audience are ISVs, you can all participate in that program for your own application. If you've deployed an application into the wild for consumers or customers to use, you can participate by going to winqual.microsoft.com and signing up. You will then go through a process where you match your particular binaries and the builds that they are to your company. And then you'll have access to all the crash dumps that are coming into Microsoft. But a little-known fact is that for enterprise customers, if you're developing line-of-business applications that are deployed within your organization, you can actually also have that type of support directly for internal apps. It's something called corporate error reporting. I've put a link to it here, but basically it stops the crash dumps being transmitted from your users' desktops to Microsoft, and instead will keep them on a server that's directly in your organization. So no information leaks out unless you really want it to. And you have the access to all of those crash dumps to be able to focus on that. Of course, can I get another poll, managed code users in the audience? So it's been pretty tough so far to be doing managed debugging and mini dumps. So new for Visual Studio 2010, we have support for writing and reading mini dumps from processes with managed code at last. We also have support for mixed mode debugging in x64, something that's been on our customers' minds a lot. And both features are working against the CLR 4.0, and I want to give a shout out to the CLR guys who helped us build this particular feature. So with that, I'm going to jump into a demo again, show you just how that works. So I'm going to let this particular code continue. Take this breakpoint out. And create a crash in my managed code, an unhandled exception. Because it turns out that coin flip isn't particularly the best way to think about how you should be buying stock. So that's going to crash and come up inside Visual Studio. Yes, it is. Anytime now? All right. Not so much. I've got an unresponsive Visual Studio. Okay, I'm on virtual PC. I'll start again. So I'm actually using the bits that are on the hard drives that you're going to get today. You'll be able to play with both the, oh, there we go. I think we actually got the crash eventually. You'll be able to go and play with both the breakpoint tagging and filtering feature as well as the mini dump reading and writing support. So here we are, an argument out of range exception. But it turns out I don't know how to debug this. I'm not super great on managed code, or I don't own this code. So I'm going to go ahead and go to the debug menu and do save dump as, new for 2010. And let me create a new one. Demo 3. Save that off. Let me close this solution now since I don't need it. And when that's finished writing, I'll be able to pick it up in this other Visual Studio, which is also not responding. And what we do here is we open the project, but we actually navigate to the dump file as that project. So I wander into .demo. And here's the 3 file that I created. We open that up. Hit F5. And almost instantaneously, in the other Visual Studio, I have the crash dump ready to be debugged by someone else. So we chose this time around to actually, every time we have a mini dump, that we're actually going to open it up as a mixed mini dump. But we would like your feedback on that particular choice, because we felt like a lot of our ISVs have mixed and managed code, so we decided to go in that particular direction.
Question?
Yes, question at the back.
Will editing continue work for 64-bit?
So the question from the audience was, will editing continue work for 64-bit? And the answer is, not this time around, I'm sorry. But we would like your feedback. Thank you. When you're post-mortem debugging, I want to just quickly touch on native optimized debugger tips there. You're always going to end up doing some level of optimized debugging because of the fact that your crash dumps are coming in from the wild and it's your full optimized code that's out there. My biggest tip is take the red pill. You know, don't take the blue one, take the red one. It's the real world of what's really going on. The disassembly window and the autos window, when you're in disassembly mode, will actually show you the pertinent registers from where your IP location is. They're the best things to tell you exactly what's happening in your application. You can trust statics and globals and trust the stacks when you have symbols. You have symbols, right? Don't necessarily trust the watch and the locals. These are the places where the most code optimization has been going on. The compiler has been hoisting variables, taking them out of scope, changing their lifetime, and the debug information isn't rich enough for us to make an educated guess about what that particular is. An article by one of our team members, Greg Miskelly, is a lot deeper dive on this optimized debugging place. The other thing I'd say is don't trust, if you're doing live native debugging, live optimized debugging, don't necessarily trust stepping. The compiler will move lines around, and again, the symbolic information is not accurate enough for us to be able to do what you necessarily expect from stepping. Stepping in disassembly will always do what you expect. So how does the debugger do mini dumps? Well, in common with DBG, we use the dbg help.dll method, mini dump, read dump stream, to read streams from a mini dump file. It's just a very big collection of snapshots of data that are pushed into a target file. We read things about the system to understand whether it's x86 or x64. We read all the thread information to populate our threads window, what modules are there so that we can go and load all the symbols for those DLLs that were loaded at the time of the crash. And the memory list stream is the stream that tells us which portions of memory have been read at the time and written back to the mini dump that we can count on when we want to go and evaluate variables or walk stacks. And then we create container objects down in the bowels of those engine components that I showed you earlier to be able to wrap those. And we only page memory in from the mini dump file as we need it once we've taken it. So that's pretty much it for my talk. I'm going to point you to some resources, some blogs from our team members who always are showing tips and tricks. For externals, I'm going to plug John Robbins from Wintellect, who's always got something to say about debugging. And Tess Fernandez, even though she uses WinDBG an awful lot, is one of the best people that does a huge amount of debugging. Great tips there. I also want to point out related sessions. There are some that have been in the past. I'd ask you to go and check those out on recordings on Channel 9. Coming up, there's also Steve Carroll's talk on improving .NET performance and scalability. The CLR Futures talk might mention some more about mini-dump debugging. And Daniel Moth's talk will actually show some of the advances that a sister team of ours has done in showing multi-threaded and highly concurrent applications in the debugger. The other thing I want to invite you to is to come forward and ask questions at the end here. The team is available for a Q&A session that we're going to have over at the VSTS pavilion inside the big room. Members of the whole team are going to be there. I also want to plug, directly after this talk, John and myself are hosting an open space in the open space area in the big room on futures of debugging. What are the problems that people are facing now, and what are they going to face in the future as we see this paradigm shift into the cloud world and into the Azure services. What is it going to take to build the right tools to support people like that? What are the problems they're going to face? So we'd love you to come. We'd love to hear your ideas and hear some of the industry experts like John and Pat, David Gray, the lead for the application flight recorder, and come and talk to us about what you think, what your thoughts are there. And with that, that's it. Thanks very much for coming. Questions from the floor? Can you give me level? Questions from the floor at all?
When is the pavilion thing that you mentioned?
It's at 1:45 today. The open space is at 1:45. Meet the team is at 3:30. Sir, if you could use the microphone, that would really help, actually. Thanks.
One problem I've run into is that if you have, let's say, hundreds or even thousands of instances of a particular class, and you'd like to stop the execution or put a breakpoint only when one particular instance is being executed, there's no easy way that I've been able to see to do that.
So I'm just going to ad hoc a demo here, see if it works. One of the ways you can do that is that we have this mechanism new in 2008, I believe, or was that a 2005 feature? 2005 feature? You can go to, let's take this watch one, locals, here we go. So I can do a make object ID operation off the right click here on this particular object. And that's giving me that £1 sign. Now I can go ahead and use that as an expression in any conditional variable now. So now I can say, okay, here's my condition, stop when this equals £1. And so it's limited. You can only have a set number of these object IDs. I wouldn't recommend that you create thousands of them. In fact, I think the CLR is limited in how many it will give us. But that's the way to go and enable that particular thing. So, sir?
I just want to clarify, meet the team is at 3 o'clock where?
3:30. 3:30,
sorry,
meet the team.
3:30, and where is it?
It's in the VSTS lounge area. It's right next to the big black modeling Oslo balloons.
All right, thanks. I have two questions. The first is real easy. The second one, maybe not so much. The first one is for debug build. When I run without debugging, am I running the debug build?
If that is the active project configuration, that is true. The debugger actually goes and asks the project system, hey, what's the target output from your current configuration?
Okay.
And that's the one that we go run.
So it's a debug build, but without the infrastructure of the debugger.
Right. We're not connected, so we don't connect to, is it managed or native?
Managed.
So in managed code, we would normally connect to the CLR and say, hey, we want to have a debugging conversation with you, but not if you're doing Control F5.
Okay, my second one, well, I want to thank you personally for creating a great debugger. You've made my life much, much better over the years. Really.
I'm going to make the team take a bow there as well.
I'd shake your hand
because
if
it's
I
not
were
just
closer
me.
to you. Maybe I'll get a chance later. One of the great things about .NET and the later versions of Visual Studio to me is the similarity of behavior between debug and release builds. That's really, really improved over 8 or 10 years ago in native code.
Yep.
And one of the things I've noticed is almost always debug and release builds behave similarly, including when the debug build is being run on the debugger. But my question is, what scenarios are likely to create a difference there? And under what scenarios is a debug build, let's say in a debugger, likely to behave differently?
So there's one interesting facet of what we do in the debugger here that's very subtle and people don't realize. I think I'm going to, again, ad hoc a demo here. But in the debugger options, even if you have a retail build, if you press F5 and launch it under the debugger, some of the where is it? Can you remember where this option is, Monica? So you can see here, suppress JIT optimization on module load is on by default in the debugger. So every time you F5 and launch the process, we're going to switch the JIT optimizations off. And that just helps with the amount of variable inspection that you can do in any given build. you'll be able to quickly see if you turn that checkbox off and run your retail build with F5 on the debugger, or if you attach to a retail build, what some of the differences are. But it's really going to be specific to which variables you can inspect, what the lifetime of those are. Stacks are going to be solid. That's irrespective of these JIT optimizations. Definitely grab the team, though, and we can go into more details with that. And we've got some of the CLR debugger team right in the audience as well, so we're happy to talk to you about that one.
Great. Thanks a lot.
No, thank you.
I have 2 questions. The first one is, in C++, I was able to put breakpoints on memory to find out when someone was writing to a particular variable. And I've been waiting for that in the manager for a few years.
We've been waiting for that one, yeah.
Any plans to implement that?
So I hate to disappoint you, but it's not going to be in Visual Studio 2010. It was a feature that we discussed at length between my team and the CLR debugger team, trying to figure out how to get that done this time around, and it didn't make it this time. We still want to hear your feedback. We want to make sure that our management understands how much people are looking for that feature. But we understand it. We would want it. But, yeah, sorry.
If you can talk to us, there's a lot of deep questions about what behavior exactly you
Yep.
expect. And
Yep.
There's easier things that we can do quicker, and
Yep.
there's more complicated things that might be more what you'd expect that's going to take us longer.
So if the audience didn't hear that, Rick's asking if we can get some more detailed understanding of what the requirements are there so that we can make some trade-offs to be able to get a feature like that in the future. Yeah, John and Rick will be there at the open space, and they can.
And my second question is, do you have any guidance on the situation where you have references to assemblies, and when those assemblies are something you're debugging, basically there's no project settings that let you reference a debug set of assemblies versus a release set of assemblies?
So my advice is actually always to keep them homogeneous. I've run into too many problems in the past. It's not as bad with managed code, but it certainly was with native code, when you would mix native and debug, optimized and debug. So my own opinion there, and it's not necessarily the opinion of the CLR guys, is to keep it homogeneous, if at all possible.
But there's no way to do that without going and actually removing all the references and re-adding the references every time.
No, they will be homogeneous. The references will be homogeneous unless you're talking about system assemblies that come with the CLR.
No, I'm talking about my own assemblies.
OK, let's grab this one offline so that we can make sure we're talking about the same thing there.
Right.
All right, thank you.
So my question is, one thing that I often find painful in the managed debugger today is when I have one line, one statement that contains a lot of potential places where an exception can occur. Like if I'm doing a lot of casts, for instance, in parameters, so in a method call, and if an exception occurs, then it's really difficult for me to find out which one of those statements actually raised the exception. Is there any good workaround for that? Anything coming up in later versions that will make that less painful?
There's not in 2008. I'd love to grab you offline to just capture that one and take it back to the team.
Yeah.
It's not on the radar right at the moment, but it's something that we'll definitely go and consider.
Sure. So,
This is managed code.
yeah, this is managed.
So yeah, exception doesn't actually, there's a line that
It should highlight the statement that it thinks it's coming from in the exception assistant.
Is there a difference between VB and C# in this regard? Because I'm using VB.
They both have the exception assistant turned on.
I think the problem is if you don't check the debug exceptions, then that checkbox is not going to break.
Oh, you mean make sure it's trapped on throw?
Correct.
OK. We should look at your example if
maybe you
we
can show me how
possibly
that
can.
works.
Yep, absolutely. We'd
Thanks.
love to. Thanks.
I have a feature request, but I'm not sure who it goes to.
CLR.
Yeah, could be. Sometimes when you have multiple worker threads, they're doing something, and you'd like to be able to see that information in the thread information. And that what they're doing may change from time as they're waiting for different requests. Unfortunately, thread.name is write once. It would be nice to have some sort of status that we could display in that thread window to help us.
So the status isn't captured by the call stack itself of where the
No, because it's waiting for some semaphore maybe, and you want some context information about which request you're processing, or that kind of thing might be useful. Which user is invoking the request, or in our case, what RPC is going on at the time.
So there's some general goodness about things, is that we've added some new infrastructure. With the parallel team has added a new thing called a task. And the idea is that rather than reuse threads, you create new ones. And these
So what I would do is direct you to Daniel's talk. But if that doesn't, Daniel Moth is actually going to speak very in detail about that. But if it, that does mean taking a dependency on a new library, we'd still love to talk and figure out how we can make that happen for you.
All right. Thank you very much.
No, thank you.